Hi, Geometry, day 3 of statistics and probability, and we're going to focus a lot on two-way tables today, all right? So again, in a two-way table, remember that each cell represents a group of people that have two characteristics. So again, these 19 are males who do have pierced ears, these 84 are females who do have pierced ears, and then you have the totals, right? Um, so when you do an and problem, right, it's typically one cell. So this 19 is male and pierced ear. If you're doing an or, you have to use the general addition rule where, so say it's male or have a pierced ear, you would take all the males 90, you would take all the pierced ears 103, and then you have to subtract where they overlap, the 19, so that you make sure you don't count the same group twice. So in these problems I'm going to do with you, we're going to make two-way tables and solve. All right, so let's take a look here. All right, so yep, let's go ahead and do problem 1 here. So it says, in a math class with 26 students, a test was given the same day that an assignment was due. Oh no, that's the worst. There were 17 students who passed the test and 18 students who completed the assignment. There were 15 students who passed the test and also completed the assignment. What is the probability that a student who failed the test completed the homework? Oh my goodness. Okay, so there are two main ideas in this problem. It's about the test and about the assignment, right? So let's put our two-way table. How are we going to make this two-way table? There should be 9 cells, right? So let's do that. So 1, 2, 1, 2, right? 9 cells. So on the outside, we're going to have test, and then this is going to be the homework, okay? And for test, you either passed or you failed, and this is the total. For your test, you either, let's say, completed or not completed, all right, in the total. Okay, so pass, fail, total, completed, not completed, and total. So it says there were 26 students total, so that's the bottom right number, 26. A test was given the same day that an assignment was due. There were 17 students who passed the test. So the total number of students who passed the test is 17. And there were 18 students who completed the assignment. So completed the assignment, 18 completed the assignment total. There were 15 students who passed the test and completed the assignment. That's the one cell. Pass the test, completed, there's 15 here. And they want to know what is the probability that a student who failed the test completed the homework. All right, so let's first fill out the table. So I'm going to use a different color to fill the table out. So again, it's just adding and subtracting. So 26 minus 17, that's 9. 26 minus 18, that's 8. 18 minus 15 is 3. 9 minus 3 is 6. 8 minus 6 is 2. And 15 and 2 is 17. Good. All right. So now, when it says the word who, remember that that's the word given. So we want to find the probability that a person who failed the test did complete their homework. So completed the homework given that they failed the test. So that means we're looking for both out of all those who failed. So again, we are only looking in this table at the ones who failed the test, and that is this column right here. This total is what we're using, not this one. This is a conditional probability question. And of these 9 people, who also completed their homework? And that was these 3. So poor people who failed the test but did the work. It happens. And we divide by 3, and this simplifies to 1/3. And that should be the answer. All right. I cannot guarantee that they're all going to be conditional probabilities. This who might not be the answer, might be given to you. Let me see if I can find one where that's given to you, and we'll do another one of these. All right, so let's take a look here. It says in a math class with 20 students, the test was given the same day as the assignment was due. There were 12 students who passed the test, 13 who completed the assignment. There were 10 students who passed the test and also completed the assignment. What is the probability that a student chosen at random from the class passed the test and completed the homework? All right, so same kind of setup, right? So we need our table with 9 boxes. So this is the test up here. This is the homework here. Again, completed, not completed in total. pass, fail, and total. So there were 20 students this time. Uh, 12 passed the test. 13 completed the assignment. Now, this question right here, this sentence, there were 10 students who passed the test and also completed the assignment. So to me, that is going to go in the spot where you have passed the test. So they passed the test and they completed the assignment. That's going to go right here, right? So that is this 10. So passed the test and completed. And the question is, what is the probability that a student chosen randomly from the class passed the test and completed the homework? Okay. So if we take a look here, let's fill in the rest. So subtract 8, subtract 7, subtract 2, subtract 3, and then subtract is 5. If we add 3 and 5, we get 8. So we want to know, what is the probability that a person from the class passed the test and completed the homework? So this is going to be one cell, the passed and completed. So that's going to be this group of people, but then it's out of the total this time. This is not a conditional probability. So this is just the probability of it passing and completing. And that's just going to be a simple out of the 20, that was 10. That's going to be a 1/2. So there's an example that's not a conditional probability question. All right, I'm going to do one more of the other type, and then that'll be all for this. Okay, let's see what this one said. It says, this season, the probability that the Yankees will win a game is 0.49, and the probability that the Yankees will score 5 or more runs is 0.56. The probability that the Yankees lose and score fewer than 5 runs is 0.36. What is the probability that the Yankees will win when they score fewer than 5 runs? Okay, so a couple of things here. First, we have to build our two-way table. So we're talking about winning and scoring runs. So here's my two-way table. So at the top, we'll talk about winning. On the side, we'll talk about scoring. So we either win, so win or lose. And over here, score, we're doing 5 or more, so greater than or equal to 5 or less than 5, and then the total. So they give us these probabilities as decimals. So we can do this two ways. We can put a 1 in the bottom corner, or we can put a 100. If we put a 100, we don't have to use decimals. I'm going to put a 100, okay? If you want to use the decimals, you can put a 1. It's fine. So the probability that the Yankees will win is 0.49. So a win is 49. So 49 times they'll win. The probability that they score 5 or more runs, so 5 or more runs, is 0.56, 56% of the time. The probability that the Yankees lose and score fewer than 5 runs is 0.36. That's this box right here. Lose and score fewer. That's 36. What is the probability that the Yankees will win when they score fewer than 5 runs? That's given. So be aware of that. This is a conditional probability. All right, let's fill in the table. Do some subtractions. 100 minus 56 is 44. 100 minus 49 is 51. 51 minus 36 is 15. 44 minus 36 is 8. 56 minus 15 is 41. 41 and 8 is 49. Okay, so we want to know, what is the probability that they'll win given that they score fewer than 5 runs? Probability of winning given that they score less than 5 runs. Well, that's going to be both over the less than 5 runs. So we're looking at the less than 5 runs row, and that means 44. We're not using in the 100. So my bottom number is 44. And in that row, when do they win? They win 8 times. We're going to divide that and round to the nearest thousandth. So we do 8 divided by 44, and I get this. 0.181818, tenths, hundredths, thousandths. The 8 rounds the 1 up to a 2. 0.182. 0.182. Okay, So again, this is their example of using 1. I use the 100. But again, I don't know when it's going to be conditional. When it's not, you just have to read the words and do your best job deciphering. Okay? If you have any questions, just feel free to ask. All right. Good luck.